Hello and welcome to this NDAR Naval Architecture video, part of the NDAR video library. This video features the Orca3D plugin for Rhino 3D V8, created by our excellent partners at the Orca3D software house. Orca3D offers a complete set of naval architecture tools. In this video we'll review and explore the Orca3D Hull Assistant toolset. The Orca3D Hull Assistant toolset is designed to generate early design hull models in a short time, thereby allowing various naval architecture and design activities to be carried out in parallel from the earliest stages of the design cycle. The end goal is to fully validate the design in the shortest possible time. More videos addressing the overall design ecosystem are available from the NDAR and Orca3D video libraries. This video is divided into 7 sections. Create a new file using the Large Objects Meter template. Here are the target values of the hull's main particulars and coefficients that we seek. Now we will set some Rhino and Orca parameters. From the Tools pull-down menu, open Options. In the Units panel, set Absolute Tolerance to 1 mm, the Angle Tolerance to 1 degree, and Display Precision we will set also to 1 mm. Model units are already set to meters as we have used the Large Objects Meters template. Click OK. From the Orca3D pull-down menu, open Properties. Change current units to SI ton. Set model orientation forward to positive X and up to positive Z. In the Hydrostatic tab, leave fluid type as seawater and keep the rest parameters with default values. Click OK. The message you will see says that changing the Orca3D model orientation doesn't transform your Rhino model. These settings provide information for Orca3D about the current orientation of your model, which are used in various analyses. From the Orca3D pull-down menu, open Hull Design, Hull Assistant. There are 5 types of hulls which can be designed with Hull Assistant. For the dry cargo vessel, we will choose Ship Assistant. Open Assistant. Change the description to MSNDAR. There are 4 tabs in the Ship Hull Assistant window. Dimensions, Hull Form, Bow Transom and Bow Bulb. We will start with main dimensions of the hull. Set length on deck to 113 meters. Beam on deck to 15.2 meters. Depth at bow to 9.85 meters and depth at transom also to 9.85 meters. Set draft to 7.1 meters. And transom height about baseline to 6.2 meters. During the design process, we would like to see the current stage of the shape, and changes were produced by changing the different parameters. Check the Preview Hull checkbox. We would also like to see the sections. If necessary, custom sections can be defined. We can also get a live preview of 4 selected hydrostatic parameters at a time. You can choose from a list of available parameters. We will choose block coefficient, water plane coefficient, displacement and vertical position of center of buoyancy. By default, seaplane origin is located at the intersection of center line, draft water line, and forward perpendicular. We would like to change so that it will be located at 2.75 meters from transom and at the baseline level. To achieve this, we need to shift the hull in 2 directions. We need to shift it 110.25 meters forward and 7.1 meters up. Notice how the shape and hydrostatic parameters are changed. When we change the transom height, you will see that shape is changed and hydrostatic parameters are changed as well. We will proceed with the setting up bow's transom parameters. Switch to the bow transom tab. Stem rake defines the angle between the stem and vertical direction. We will set it to 37. Stem curvature parameter allows to define the straight, concave or convex stem. We will set it to 0 to have a straight stem. Bow rounding is responsible for the fullness of the water lines at the bow. We will set bow rounding to 0.21. For foot shape allows to change the rounding between the keel and stem. We will set this parameter to 0.68. Transom rake defines the slope of the transom. We will set to 0 to have a vertical transom. Transom deck width. We will make the deck width at transom slightly smaller than the mold beam and we will set it to 0.95. Keel rise point parameter allows to control the aft ship shape run from bottom to transom. We will set keel rise point to 0.7. Increasing vel 0 pushes the point where the keel begins to rise further aft. We'll set it to 0.31. Increasing vel 1 increases the distance forward of the transom where the centerline begins to drop towards the baseline. We'll set vel 1 to 0.19. Now we will switch to the hull form tab. Maximum area location will be located near the midship frame, so we will set the maximum area location parameter to 0.52. From the current status of hydrostatic parameters, we see that we need more volume below the waterline. We can achieve this with longitudinal prismatic control parameter. We'll set it to 0.75. Shape fullness of the aft, middle and forward frames can be also controlled by the section tightness. We will set forward tightness to 0.8. Midship to 0.25 and aftship to 1. Dead rise controls the bottom slope at the aft, midship and foreship. We will set all these parameters to 0. Side slope controls the slope of the side shell at the aft, midship and foreship. We will set foreship side slope to 0.5 and midship and aftship to 0. Flare controls the curvature of the side shell at the aft, midship and foreship. We will set foreship flare to 0.6, midship and aftship to 0. We don't plan to have any shear, so shear heights we set to 1, which means the horizontal flat deck. Fullness at the foreship we will set to 0.5 and the aftship to 0.4. Now we will add the bulb and fine-tune the shape. Switch to the Bow Bulb tab and check the checkbox Create Bulbous Bow. Set bulb length to 3.3 meters. Bulb width to 4.5 and height to 4.2 meters. We see that values of the block coefficient and water plane coefficient are higher than expected and we need to adjust some parameters. We choose to intervene on the longitudinal prismatic control parameter in the hull form. We will change it to 0.75. Thus, we have matched concept target values closely enough for this hull to be used as base for ensuring design work, to hydrostatic initial check, compartmentation and damage hydrostatic, CFD, 3D general arrangement, preliminary structure layout, seakeeping, etc. Save settings. Now we can create hull. Open the pull-down menu and select Create Full Model. This concludes the presentation of the Hull Assistant toolset. Thank you for watching this NDAR video featuring Orca3D.